All right, let's jump right into one of the biggest first steps in understanding data, quantitative variables. Now, I know that sounds super technical, but I promise you, it all boils down to a really simple idea, the difference between counting something and measuring it. So, to get your brain warmed up, just think about this for a second. How is counting up the number of students who got an A on a test different from looking at the exact score, like an 88.5 or a 92.3 that each student got? I mean, they're both numbers, right? But they tell us fundamentally different things. And figuring out that difference, well, that's exactly what we're going to do today.
So here's our game plan. We're going to follow a student's first brush with data, then we'll dive into the world of counting, and then the world of measuring. After that, we'll see why it all matters, and we'll wrap it up with a super handy cheat sheet so you'll never forget this stuff.
Okay, let's get into it. And to do that, let's imagine a scene that's probably pretty familiar to a lot of you, a first-year university class. This is Maya, and she's our hero for this story. She just got her first big stats assignment, and it's pretty simple, really. Go collect some data about your classmates. So she's got to figure out what she can actually turn into numbers. And what she's on the hunt for are called quantitative variables. You know, it's just a fancy name for anything you can put a number on, whether you're counting it or measuring it. This is basically her entire toolbox for this assignment. So Maya thinks, okay, where do I start? She decides to go for the low-hanging fruit, the simplest, most direct numbers she can get her hands on. And this leads her to a really important discovery. Welcome to the world of counting. Her first move is super straightforward. She just looks around the lecture hall and counts how many people aren't there. A simple head count of absences. On Monday, she looks around and jots it down. 2 absences. That's her first data point. It's a nice, clean, whole number. Can't get much simpler than that. Then on Tuesday, she does it again. This time, it's 3. Now see what's happening? The value literally jumps from 2 straight to 3. There's nothing in between. And this is the whole key right here. You can have 2 people absent, or you can have 3 people absent, but there's no way you can have 2.5 people absent, right? The values are totally separate, individual, distinct things. And this is what we officially call a discrete variable. It's a number you get by counting things, one by one. And it always answers the question, how many? Just think about it in your own life. The number of courses you're taking this semester, the number of cars you see in the parking lot, or, even the number of mistakes on a test. You count them. They're all discrete variables.
Okay, but Maya's assignment isn't just about counting. She needs more data. And this is what pushes her out of the world of counting and into a totally different territory, the world of measuring.
So, the professor hands out a surprise pop quiz. Perfect. Maya's new task is to record the exact time it takes each student to finish. She gets her stopwatch ready to go. The first student turns in their quiz, and Maya hits the timer. 12.4 minutes. And boom, right away you can see this is a different kind of number. It's got a decimal. This isn't just a simple count anymore. And what's really cool about this is that the number isn't fixed in stone. If she had a more precise stopwatch, maybe it would have been 12.41 minutes, or with an even better one, 12.415 minutes. The value can be anything along a smooth, unbroken scale. And that, my friends, is a continuous variable. It's something you measure, and it can take on literally any value within a range. This type of number answers a completely different question. How much? A student's height, for example, or the exact temperature in the classroom. Or, going back to our first example, a test score of 87.5%. These are all things you measure, and they can all have those in-between decimal values. All right, so let's take a breath. We've got these 2 worlds, counting things, which gives us discrete data, and measuring things, which gives us continuous data. But here comes the million-dollar question. So what? Why on earth does this actually matter? Maya's got her 2 neat lists of numbers. One is a list of counted absences, the other is a list of measured quiz times. So, what now? Why was it so important for her to know which was which? Well, let's start with her discrete data, the absences. A bar chart is absolutely perfect for this. See? Each bar is a student, and the height clearly shows a distinct number of absences. It's clean, it's simple, it's easy to understand. But now, what happens if we try to force our quiz times into a bar chart? I mean, are we supposed to make a tiny little bar for 12.4 minutes and then another one for 12.41, and another for 12.415? Oh man, it would be a complete and total mess. It just doesn't work. Exactly. It doesn't work. And that gets us to the most important takeaway of all. The type of variable you have literally determines the tools you can use to analyze it. For continuous data, like quiz times, we use something called a histogram. It looks a little like a bar chart, but instead of showing individual values, it groups them into ranges, or bins, like how many students finished between 10 and 12 minutes. This lets us see the overall shape of our data. So the variable type tells you which chart to use, which stats to run, everything. Getting this first step right is absolutely crucial. Okay, we've been on this whole journey with Maya, from counting to measuring to charting, so let's bring it all home and put everything we've learned into one simple, final cheat sheet. And here it is, plain and simple. Discrete variables, you can count them. Continuous variables, you have to measure them. Discrete values are separate, whole numbers like 1, 2, 3. Continuous values can be anything in a range, like 1.5 or 2.71. Discrete answers how many, while continuous answers how much. And as we saw, that means you use a bar chart for discrete data and a histogram for continuous. It really is the foundation for everything that comes next. So I'll leave you with this question. Just think about your day so far. The number of cups of coffee you had, the amount of time you've spent scrolling on your phone. Now you know there's a difference. So, what have you been counting today, and what have you been measuring?